As mentioned, the climate motivation is one of the major motivations for energy discussions. As we all know, when we use energy, we use carbon based. For example, it's a fossil fuel based, and fossil fuel is mainly based on a lot of carbons there. So we need carbon, and then for burning fossil fuel, we need oxygen as well. So carbon plus oxygen will result to a chemical reaction of carbon dioxide plus, of course, the heat is being produced. So we have carbon dioxide emission coming from the burning of fossil fuel. And this is the major issue here because carbon dioxide is considered as a greenhouse gas. All right, naturally, actually, the greenhouse gases is a natural phenomenon, but because of the increased amount of carbon dioxide that is being emitted now, so there will be more greenhouse gases on Earth. So that's why it has more warming effect, which I will explain in the next slides. If with these greenhouse gases, it affects the overall global temperature. In fact, it has now increased to more than 1 degree Celsius of temperature since pre-industrial times. This is the increase in global temperature. And just a minor increase, with just 1 degree Celsius, is actually quite a very big increase already because it affects on a lot of things. It has effect on melting of ice caps. Therefore, when ice caps melt, they are formed into liquid and go to the ocean. And of course, when the ocean is added with more volume, then it will result to increase in sea level, and also, of course, it will have some damaging effect to the environment. So the atmospheric CO2 has been increasing very rapidly since especially during the Industrial Revolution. So from 1751 here, 2 billion tons of CO2 in 1900, and then from 2 billion, you can see the big jump, 36 billion in 2017. That's 36 billion tons in 2017. And the amount of atmospheric CO2 concentration has been increasing quite high as well. As you look from here in 1955, for example, it is around only 310 ppm, parts per million. All right, so some 310 ppm, it has now increased to around 404 ppm in 2017. And I checked just recently in February, just this year, the parts per million, the concentration of carbon dioxide is actually around 414 ppm. All right, that's quite very high now, and we're trying to target back below 350 ppm or much lower. And so that's why we have a lot of different policies and approaches to do this in reversing the amount of CO2 concentration on our atmosphere. So the most extensive source of analysis with regards to this potential impact of greenhouse gases, you can find it in the 5th Intergovernmental Panel on Climate Change, or IPCC, which is a report in 2014. So please kindly check this document for more detailed analysis of the effects of greenhouse gases on climate change. IPCC is actually the UN, the United Nations body for assessing the science related to anything related to climate change. So this is a very important document that you need to at least read and see the values there. So this amount is the highest level of CO2 concentrations in about 800,000 years. So that is a very, very alarming values, the very alarming news that we are increasing so much in terms of concentrations, which is related to the increase of our global temperature. As I mentioned, the climate change is mainly because of the effect of our anthropogenic activities or human-based activities. As you can see from this figure here, if you're looking at from year 1000 and to the probably around almost 1800, you can see that the CO2 concentration on Earth are mostly constant because it's just a natural phenomenon. The Earth is just more neutralizing itself. But because of the industrial revolution now, wherein fossil fuels have been used more and more, then there's a sudden change in the CO2 emissions. and then the CO2 emissions because of the use of carbon-based materials or fuels, then there is an enhanced greenhouse effect because this is a greenhouse gas. So the more CO2 in the atmosphere, then there is a more trapping ability of the Earth to trap the heat inside the Earth. That's why our temperature has been increasing sharply in the past many years, from 1750 from 280, and then in the current year at 414 ppm. And as I mentioned, we have increased about 1 degree Celsius in global temperature already, and we're trying to control this one below 2 degrees Celsius as being still safe enough for us to live. But beyond 2 degrees Celsius, that will be a lot of very difficult things that will happen. In fact, 15 of the warmest years on record have occurred already in our current century, the 21st century. 15 of the warmest years on record. So this is a very alarming message here that global warming is really real here. Climate change is real. And it is evidence-based. As you can see here, there's an evidence that population growth and activities of the human have really made it go up really high in terms of emissions. And that the predicted temperature variation due to natural causes over this rate shows no rise at all. So this is basically based on the natural phenomenon of greenhouse effect without the cause of more human activities. But see, here is a different story. Let us talk about greenhouse effect. What is it exactly? So as we know, the Earth is receiving a lot of energy from the sun, and this is the main source of our energy. So when solar radiation reaches the Earth, some of these, or 1/3 of the solar radiation, is actually reflected back to space. But 2/3 of this goes to the Earth, and the rest of the sun's energy is absorbed by the Earth, actually. That's why it's heating our land, our oceans, and heating the whole of Earth. Because of the heating effect, then it becomes warm. It also emits a lot of infrared radiation. And this infrared radiation is actually directed back to space. But some part of this infrared radiation is being trapped by the greenhouse gases, especially the most common one, the most abundant greenhouse gas is actually the water vapor in a natural phenomenon. But because of the increased human activities like fossil fuel burning, agriculture, land degradation, and all of these things, it releases more and more greenhouse gases. So because of the enhanced value or enhanced concentration of greenhouse gases on Earth, now there is more chance, or there is now more ability of Earth to trap more heat rather than compared to the conventional or the natural phenomenon of the heating of the Earth. So because of this more greenhouse gases concentration, the Earth can be heated more, and that's why we have this term of global warming, because of the trapping of the heat by more concentration of greenhouse gases. So these human activities clearly shows the effect of these human activities on greenhouse gas levels in the atmosphere. It cannot be denied that the activities of burning of gases of fossil fuels have resulted to enhance greenhouse effect, and that's why global warming is an issue now. There are many greenhouse gases on Earth, and one of the most common one is the most usual in natural phenomenon is actually water vapor and water droplets. All right, without the enhanced or the increased greenhouse gases from these gases from here, water vapor is there to actually trap heat and have our natural heating phenomenon on Earth for our survival. But because of the enhanced effect of the increase in concentrations of these greenhouse gases, then we have a heating problem now in our global warming. So these greenhouse gases are actually conventionally expressed in equivalent amounts of carbon dioxide. If you look at the various greenhouse gases here, we have carbon dioxide, we have methane, nitrous oxide, FFCs, PFCs, and so many others here. You can see that the carbon dioxide is basically the majority of these greenhouse gases. You can see from here, majority of the manufacturing process power plants are releasing CO2s. and this takes up around 76% of the overall greenhouse gases. So that's why in most cases the greenhouse gases is based on CO2. But of course, we have other greenhouse gases here, like for example methane and nitrous oxide. Methane is composes around 15% and 7% for nitrous oxide of the overall amount of greenhouse gases. But these have different levels of the way they absorb heat. All right, so this absorption of heat, depending on the kind of greenhouse gas, is basically referred to the global warming potential. The global warming potential is the amount of warming a gas causes over a given period of time. So for example, how long they actually stay on the atmosphere. Normally it's around 100 years. So the GWP, or global warming potential of CO2, is 1 because it is the basis, is the reference value, because most of our greenhouse gases is based on CO2. But methane here has a global warming potential of around 25. Before, previously it was 25. Now IPCC says it's around 34 to 86 of global warming potential. So basically, let's say 34. So when we have around 1 ton of methane, the global times the global warming potential, because the warming contribution is basically the mass of that GHG, or the mass of greenhouse gas, times the global warming potential. So if we have 1 ton of methane, it means it is capable of contributing to warming to about 1 times GW2, which is 1 times 34. It is about 34 metric tons of CO2 equivalent as a global warming potential or warming contribution of methane. So it means a small amount of methane will have a really big effect on the global warming potential. The same way with nitrous oxide. So it's even more, it's even worse, because it's around 300 times of based on CO2 level. All right. So normally we express these CO2 emissions or gas emissions by equivalent amounts of carbon dioxide, or CO2 equivalent, because everything is based on CO2 as the main reference here. So if it is if the GHG is methane, we can convert the methane effect by means of CO2 equivalent by multiplying this global warming potential. All right. So the global warming potentials I mentioned is the ability to trap heat and how long they stay in the atmosphere of specific greenhouse gas pollutants. So we can also have, as a convention, we can say that 1 ton of carbon dioxide equivalent may be abbreviated as 1 T CO2 sub E. So this is E is equivalent and T is the metric tons. And metric tons is basically equivalent to around 1,000 kilograms, or if you look at it in a more imaginative way, you can say 1,000 kilograms is a weight of a female giraffe, the animal. All right. And in most cases, if you're talking about the world emissions, it is going to be in terms of gigaton CO2e as CO2 equivalent. So when we talk about greenhouse gases, as I mentioned, in a normal case, water vapor is already a greenhouse gas, but the increase of more human activities that resulted to burning of fossil fuels has increased the amount of CO2 in the atmosphere. That's why there is an enhanced greenhouse effect. So this CO2 is the main culprit here. So this is 76% of the total greenhouse gases, and that's why we use CO2 as our reference guide for emissions. While we are talking about CO2 emissions, let's take a look in where in the world exactly that emits the most carbon dioxide CO2 emissions each year per person, per capita. So this is based, these graphs are based on the energy production, but not on the consumption or including the trade. So this is just basically on energy production. So if you look at this graph over here, you can see from 1800 to around 2017, there's a lot of changes in terms of CO2 emissions. And if you can see here, I really highlight this one. Australia is basically the highest in 2017 in terms of per capita CO2 emissions. All right, so we produce a lot of energy. It doesn't mean that we consume all of this energy because, as you know, Australia is the number 4 um, coal exporter in the world. So we produce a lot of coals in Australia. It's one of the major sources of our economy in Australia. And for per capita, we release about 17 tons of CO2 per person. This is because we have a big country, but not many populations. So we produce a lot of energy. We produce a lot of coals, for example, but we don't have that much people. We have around 25 million. So if a per person basis, based on the energy production, we still produce the most emissions in per capita in the world. This is followed by the United States, and then followed by also Japan, and also Canada as well. But you can see there's always a changes from the US based per capita before, and then now Australia is overtaking. And this is not so good because this is emissions, this is CO2 emissions. And so India is also climbing up because they're a very big country, so they have a lot of population. So if we compute their energy production per unit or per person, then they don't have that much. China is the same. This is a very populous nation. But at the end, still, it's not good to see that, in fact, Australia is one of the highest, in fact, the highest emitter of CO2. So it's a very affluent nation in terms of releasing CO2. You can see also from here the CO2 map, emission map for just energy production. All right, this is not for consumption. So Australia is leading the way in that, in a negative way. US as well, and some. So the darker the image here, or the color here, that means the higher the CO2 emissions are. If you look at who emits the most CO2, okay, so this is the global CO2 production based on where the carbon dioxide is produced, not where it is consumed. This is different. So if we produce some carbon dioxide, it means we get the source there, but in most cases we actually export many of these sources, many of these fuel. All right. So based from the production or most emission of CO2, China leads the way. So the China right now, basically China has a lot to do with CO2 emissions in terms of production. It's around 9.8 billion tons of CO2, and that's really almost times to the US one. All right. So the reason for this is actually these days China also leads the way in the production or creation of renewable energy technologies, basically. So what they are doing is actually they're rapidly increasing their production. They are making a lot of more solar farms, a lot of wind farms as well. They built the Three Gorges Dam. This is the largest in the world in terms of capacity. So the dam itself has a lot of concrete there and cements there that also contributes to the production of CO2. And also we have India here at 2.47 billion tons of CO2 emissions, and Australia is not is a little bit lower compared to this one, but still we emit a lot of CO2. So we have 14 million tons of CO2. So what you can see here does not really reflect the consumption. It's just mainly on the production, but at least it gives you an idea which area in the world has some of the responsibilities of producing a lot of CO2 emissions.